Welcome to True Projects. In this video, we are going to explain about the project, which is analysis and prediction of students' academic performance based on educational data mining. The development of intelligent technologies gained popularity in the education field. The rapid growth of educational data indicates that traditional processing methods have limitations and distortion. Therefore, reconstructing the research technology of data mining in the education field has become increasingly prominent. Traditional methods of assessing students solely based on absolute scores, and they have limitations due to variations in course difficulty and grading standards. Educational institutions need a more sophisticated approach to gauge students' learning outcomes accurately. The project recognizes that a more nuanced approach is needed to ensure the quality of education and provide meaningful insights into the students' performance. The project addresses the need of evaluating students' academic achievement in a comprehensive and objective manner. We employ advanced clustering algorithms such as K-means and fuzzy C-means to categorize students based on their academic data. This approach provides an objective and quantitative assessment of academic performance, transcending traditional grading limitations. The primary goal of the project is to enhance the evaluation and prediction of students' academic performance within the educational context. We aim to utilize advanced clustering algorithms like K-means and fuzzy C-means to objectively categorize students based on their academic data. And we also apply a range of machine learning algorithms including random forest, decision tree, KNN, SVM, and deep learning techniques like CNN with LSTM, implementing a voting classifier to combine the predictive power of multiple algorithms. The ultimate aim of the project is to revolutionize the assessment of students' academic achievements in a manner that transcends the constraints of conventional grading system. By offering objective evaluation, accurate predictions, and actionable insights, the project strives to enhance the quality of education, optimize resource allocation, and empower students to excel in their academic pursuits. Requirements needed for the project are hardware and software. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules for implementing the project. The first one is importing the packages. This module involves importing necessary libraries and modules which are NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualizations, Scikit-learn for machine learning. Exploring the dataset. This module focuses on examining the pre-processed student performance dataset. It includes tasks like data loading, checking for missing values, exploring data distributions, and gaining an initial understanding of the dataset structure. Visualization data using Seaborn. This module involves creating data visualizations using Seaborn library. It includes generating various plots and graphs to provide insights into the data such as histograms, scatter plots, and bar charts. Feature selection and splitting the data. In this step, the module performs feature selection, choosing relevant attributes for model training. Additionally, it splits the dataset into training and testing set, preparing the data for model building. Building the model. This module encompasses the development of various machine learning and deep learning models. It includes K-means algorithm. K-means is a clustering algorithm that partitions data into K distinct groups based on similarity, and it is employed to objectively group students by academic performance, aiding in performance evaluation. Fuzzy C-means algorithm. It is a clustering method allowing data points to belong to multiple clusters with varying degrees of membership. It provides a more flexible clustering approach accommodating uncertainty in student categorization. Random forest. It is an ensemble learning method that combines multiple decision trees for improved accuracy. It is utilized for precise predictive modeling of students' future academic performance. Decision tree. It is a tree-like structure representing decisions and outcomes based on data attributes. It helps identifying key factors influencing academic performance, aiding in decision making. KNN, which is K nearest neighbor. It classifies data points based on similarity to K nearest neighbor in the training set. It is applied to classify and predict student academic outcomes using similar academic profiles. Support vector machine, which is SVM. It finds a hyperplane that best separates data points into distinct categories. It is employed for classifying students based on their academic data, enabling effective predictions. Voting classifier. This combines predictions from multiple algorithms to make a final prediction. It aggregates diverse model outputs to enhance overall prediction accuracy. Discriminant analysis. It identifies linear combination of features that best discriminate between data groups. It aids in classifying students into different classes, different academic performance categories. CNN with LSTM, which is convolutional neural network with the combination of long short-term memory, are deep learning architectures. They are utilized for analyzing sequential and image-based academic data, respectively offering deep insights into student performance. CNN, which is convolutional neural network. It is a deep learning architecture designed for processing and analyzing grid-like data such as images by empowering convolutional layers to automatically learn hierarchical patterns and features. It is applied for its ability to extract meaningful patterns and relationships from the image-based academic data, enabling the analysis of visual information associated with student performance. CNN with K-fold validation. It extends the CNN model with K-fold cross-validation. It enhances model robustness and accuracy while processing academic data with the help of cross-validation techniques. Coming to training the model, this module involves feeding the prepared data into the respective models and training them. The model learns patterns and relationships in the data during this phase. Flask framework with SQLite for sign-up and sign-in. This module integrates the Flask web framework with an SQLite database to facilitate user registration, which is sign-up, and login, which is sign-in functionalities. It manages user authentication and access to prediction feature. User gives input. In this step, user provides input typically related to academic data or queries about their academic performance. The given input is pre-processed and used, and within train model it is used for predicting the performance. The input provided by the user is pre-processed to align with the model's requirement. The trained machine learning or deep learning model then utilizes this pre-processed input for predicting the user's academic performance. Final outcome is displayed through front-end. The model displays the predicted academic performance or relevant outcomes to the user, providing insights, recommendations, or results based on the user input and trained models. This is the comparison graph of the project. Here on the x-axis we have the accuracy scores, and on the y-axis we have the algorithm names. This graph represents the accuracy scores of each particular algorithm. And here we are using voting classifier, which is getting the better performance, and this will be used for prediction purpose in the web interface. For execution of the project, we need to open the code folder, which contains the source code files. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which contains the algorithm information, and this will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the code folder's path from address bar of the file explorer. So we will copy this path and open the Anaconda prompt. Here we need to type cd space paste the copied path and then click on enter. This command is used to change the current directory to the code folder's path. So here current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless configured differently. And this is the localhost and this is the port number. Now we need to copy this local link provided by the Flask framework and paste it in any browser. So we will copy this and paste it in Google Chrome. Here we will paste the link and then click on enter. So the homepage of the project is displayed in the web browser, and this front end is built by using the Flask framework. Now we will click on sign up. So here we need to fill all these registration details if we are registering newly. Now we need to click on sign in because I have already registered, so I will click on sign in. Here I'll provide my credentials details, which are username and the password, and click on login. We are redirected to the homepage of the project where we need to fill all the student details and then click on predict. By that we will get the student performance is good, bad or satisfactory. Now we will fill these details. The gender is female and the age is 18. Mother's education is secondary education. Father's education is also secondary education, and the mother's job is at home, and the father's job is teacher, and the reason to join school is course, which is course preference, and the student's guardian is mother, and travel time is 50 to 30 minutes. Weekly study time is 2 to 5 hours. Number of failures in the past is 0, and the family relationship is very good, and the free time after school is intermediate. Outing with friends is high, and the alcohol consumption is very low in the workday, and the alcohol consumption in the weekend is also very low. Health status is normal, and the number of days absent is 4. Now we will click on predict. Based on the given input, it is predicted that student satisfaction level is satisfactory, which means student's performance is satisfactory. Now we will give the other student details. So the gender is male and the age is 15, and the mother's education is secondary education. Father's education is 5th to 9th grade, and the mother's job is teacher, and the father's job is other. And the reason to join school is course, and student's guardian is mother, and the weekly study time is less than 2 hours. Number of failures is 0, and the family relationship is good. Outing with friends is very high, and the alcohol consumption is very low. In the weekends also it is very low, and the health status is normal, and the number of days absent is 10. Now we will click on predict. We have missed some entries, so here the number of failures is 1. Now we will click on predict. We are getting some error. It is actually 0. We have missed the travel time to school, so we will select as less than 15 minutes. Now we will click on predict. We have also missed free time after school, which is very low. it is predicted that the student satisfaction level is satisfactory. Now we will give another student details. So here the gender is male and the age is 16 and the mother's education is 5th to 9th grade. Father's education is also 5th to 9th grade. Mother's job is other and the father's job is service, and reason to join school is course, and the student's graduation guardian is father, and the travel time is less than 15 minutes. Weekly study time is 2 to 5 hours. Number of failures in the past is 1, and the travel time and the family membership is excellent. Free time to school is very high. Outing with friends is also very high. And the alcohol consumption level is high. And after weekend is also high. Health status is very good. Now we will enter the absent, which is 0 number of absent. Now we will click on predict. So based on the given input, it is predicted that student satisfaction level is poor. Now we will give other student details. Gender is female and the age is 16. Mother's education is secondary education. Father's education is also secondary, and the mother's job is healthcare related and the father's job is others, and the reason to join is close to home. Student's guardian is mother and the travel time is less than 15 minutes. Weekly study time is less than 2 hours. Number of failures in the past is 0, and the family relationship is very good. Free time after school is 4, which is high. Outing with friends is high, and the alcohol consumption is very low. In the workday, in the weekend, it is low, and the health status is bad, and the number of days absent is 6. Now we will click on predict. So based on the given input, it is predicted that the student satisfaction level is satisfactory. Now we will give one more student details. Gender is female, age is 15. Mother's education is primary education. Father education is secondary or higher. Mother job is civil service and the father job is health. Reason to join the school is course preference. Student's guardian is mother and the travel time is less than 15 minutes. Weekly study home is 5 to 10 hours. Number of failures in the past is 0 and the family relationship is excellent. And the free time after school is low, and the outing with friends is intermediate, and the alcohol consumption is also intermediate, and the alcohol consumption at the weekend is intermediate, and the health status is good, and the number of absent days is 10. Now we will click on predict. Based on the given input, it is predicted that the student satisfaction level is satisfactory. In this way, we can give student related details. By that, we will get whether the student performance is satisfactory, good, very good, excellent, and poor. Now we will sign out. Project successfully empowered innovative data mining and machine learning techniques to objectively evaluate and predict students' academic performance. By going beyond traditional grading methods, it offers a more comprehensive understanding of individual achievements. The application of advanced algorithms including clustering, machine learning and deep learning equips educational institutions with powerful tools for decision making. These algorithms provide valuable insights into student performance, enabling timely academic interventions and resource allocation. Through the accurate prediction of future academic outcomes, The project empowers students to take proactive measures to improve their performance, early academic warnings, and tailored support to contribute to student success and overall educational excellence. As the field of education data mining continues to evolve, this project exemplifies the potential for data-driven insights in the education. It sets the stage for data-driven decision making, ensuring that educational institutions are well prepared to adapt and thrive in the era of big data and analytics.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.